Below is a table of values of a function. Write the output when the input is n. If this looks a little bit confusing to you, it's the equivalent of what we've been doing. So if I said x plus 2 equals 3, or sorry, equals y, x is my input, y is my output. So let's just say I say x equals 3, this becomes x plus 2, or sorry, this becomes 3 plus 2 equals y, and so y equals 5. My input was 3, my output was 5. The same thing is going on over here. Basically, all they're trying to get you to do is see the pattern. Because remember, a function has a set rule, a set pattern. Some functions are through multiplication, some functions are division, some functions are addition, subtraction, or exponents, etc. They all have a pattern. So, in this case, you're trying to see how do I go from this input to this output, and which rule will work for every one of these. What I like to do is I start with addition and subtraction to see if that's going to be my pattern. So in this case, what do I add to 4 to get 9? Well, I add 5. Alright? If I add 5 to 8, will I get 13? Yeah. If I add 5 to 9, will I get 14? Yup. So I can see that given my first 3 values, my pattern is basically just, or using their variable, n plus 5. That's it. And so I know that whatever input I put in, my output, oops, that is not how you spell that. My output will be 5 more than that number. And that would actually be my answer. My answer is n plus 5. So all I did was I found the similarities between inputs and outputs. I started with addition. If I didn't find addition, I would do subtraction. If it wasn't subtraction, I'd do multiplication and then division. And I just checked to make sure it worked for each one of these. And I'd go from there. Once I find the pattern that the numbers are following, that is your output. The variable they gave you made by that example. I'll do one more example to kind of show, just in case it's different, what it looks like. So for this one, I know my output is n plus 5. Another way to think about output is what is happening to your numbers when you put them in this place. So in this case, I can already see it's not addition because I'm going from a large input to a smaller output. Now, I'm not going to start with subtraction. I'm going to start with division to show you what I mean. So, what do I divide 4 by to get 2? Well, 2. 4 divided by 2 is 2. 5 divided by 2 is not 3, so I know that divided by 2 is not my pattern. What about addition? Unless I'm adding a negative number, which is just subtraction, I'm not going to get 2. I can't multiply, well, if I multiply 4 by 1/2, I'll get 2, but that's the same thing as dividing by 2. So I'm left with subtraction. Well, 4 minus 2 is 2, 5 minus 2 is 3, 9 minus 2 is 7, so I know that my output is just the number they give me minus 2. So again, I started with division to show you how I determine my pattern. I don't just check it for one case and say, well, if that works, I'm done. I check it for all 3 cases they give me. If it works, that's my pattern. If it doesn't, try a different operation. Traditionally, in Algebra 1, you'll only be dealing with addition, subtraction, multiplication, or division. Mainly addition and subtraction. But as you go forward in your algebras, you'll hit more complex ones, like to the second power, and things like that. But outside of that, if you understand that this type of topic is just finding the pattern of how you go from input to output, That's all you need to know for a problem like this.